Welcome. In this short lesson, we are going to discuss the idea of traversing all the elements in an array list. So let's get started. The only learning objective we have for today is that we can access all the elements of an array list using a for loop and also a for each loop. Before we actually get to the traversal, we need to be aware of one method that we have not yet seen with array lists, which is the size method. And the size method returns the number of elements in an array list. So if we imagine that I have an array list on the right called list, we can count that there are 1, 2, 3, 4, 5, 6 elements indexed 0 through 5, just as it would be with an array. And in this case, list.size would return a 6. So the index values of an array list, just like an array, range from 0 to the list size -1. Just like with an array, the goal of the traversal is to start at index 0 and end at the last index, which again is size -1, and of course visiting all of the elements in between. And so it shouldn't be surprising that how we do this is very similar to how we would do it with an array, where we have a loop, I equals 0, that's starting at the first index. We are going to loop as long as I is smaller than the size of the list. Notice the less than is really important because the size of the list in this example is 6. Less than 6 means 5, and 5 is indeed the index we want to end up at. And of course, each time through the loop, we move I forward by 1. The only other difference between traversing an array list and an array is how we do our access. Remember that when we access the elements of the list, we have to use .get or .set if we want to change them. Of course, there is the alternative where if you want to, you can start I at 0 and loop while I is less than or equal to size -1. Both the traversal above and below do the exact same thing. They just are written in ever so slightly different ways. We can also do our traversal with a for each loop, also known as an enhanced for loop, and you can see the example of that here. Notice that we don't do anything with indexes when it's a for each loop. So instead we say for each integer value in the list. And so value will actually take on, well, the value of the elements in the list. Value won't be an index like 0, 1, 2, 3. It will be the elements 4, 0, 7, -2, and so forth. So of course we know there's some disadvantages to using a for each loop in terms of being able to manipulate things, but it certainly uses less code. So doing something like a simple print is much faster with a for each loop. Now, because array lists can grow and shrink as we move through our code, there are potential issues that come up when we're doing a traversal. And the one I want to talk about in this lesson is deleting while traversing. So the code on the left is intended to remove all of the 5s from the array list. And so what it does is it does a basic linear search, right? We visit all the elements with the loop. If the element is a 5, go ahead and remove the 5. And so what we might expect is that when we were done, all 3 of these 5s are gone because that's what the loop says to do. If we encounter a 5, remove it. But if we actually run the code, we don't get the output we expect. In fact, it does remove some of the 5s, but it leaves one behind. And so this code doesn't quite work as expected, and we need to find out why, and then we need to fix it. Let's see what's happening with this code by going through it step by step. So the first pass of the loop, we know that I starts at 0. And if we look at index 0, there's a 4 there, which of course is not a 5, so we will not remove it, and the loop will continue. For pass 2 of the loop, I is now a 1, so we're at the second element. And indeed it is a 5, so the loop will remove it, and the list will shrink. So remember, there was a 5 right here, but we removed it, and everything else slid to the left to fill the gap. Okay, so now we're on to pass 3 of the loop. And on pass 3 of the loop, I equals 2. So that here's index 0, here's index 1, and here's index 2. Well, wait a minute. I mean, yes, this is a 5, but what about this one before it? Well, it turns out that the loop continues no matter what, 0, 1, 2, 3, etc. But while that's happening, the array list is shrinking. So we may have removed the 5, but the code doesn't account for the fact that another 5 might slide into that same spot. And instead, the loop just goes to the next step, removes the next 5, and the result is that one of our 5s ended up getting skipped. So again, to summarize, the array list is shrinking when we remove, but the loop keeps going. And so when the array list shrinks, something might slide into a spot that we've already checked, and the loop just goes to the next spot, thus missing something. So then the question becomes, how do we fix this issue? And the answer actually is pretty simple. What we'll do is whenever we remove from the list, we are going to do I minus minus. Now, what that basically means is we're going to do the same iteration of the loop again. And here's what I mean by that. Let's kind of see how it plays out. So again, I've got my original array list at the top right, and on pass 1, we know that the first element is not a 5, so we keep going. We go to pass 2. For pass 2 of the loop, I equals 1, this element is a 5, so we remove it like such. But remember, after we remove, we are going to say I minus minus. So that means if I is 1, I minus minus is going to make it a 0, but then we will go back to the top of the loop where we will I plus plus. And that basically means we're going to minus from I and then we're going to add to it, which means that it stays the same value a second time. So normally a for loop is going to go 0, 1, 2 for pass 3, but in this case, because we removed, we're going to hold it at index 1 so that it can check index 1 again. This is important because when we delete, something else is going to slide into this slot, and so we need to check it again and not just move forward. And so indeed, index 1 is a 5, so we delete it. Remove it, and then we've deleted it. So again, we're going to do the I minus minus and force it to be at index 1 a third time to check for the 5. And so unlike the previous example where we just went I equals 0, 1, 2, 3, every time we remove, we hold the index so we can check it again. And of course, you can see that this does now remove all of the 5s. Before we wrap up, let's do a quick understanding check. And I've got the remove code that we just looked at there again on the slide. And my question is this: could we accomplish this same removal task with a for each loop? So think about that. Could we do this with a for each loop? Pause the video, and when you're ready to continue, we'll look at the answer. So the answer is that I suspect we probably could somehow get this to work with for each loops, but we'd probably have to do some coding gymnastics to make it work. And the simple reason for that is that this procedure really relies on using index values. For one, removing at the index value, though there is a way to remove from array lists without using the index, but also the idea of doing the iteration again with an I minus minus. So my answer is maybe we could do this with a for each loop, but I would say it is significantly easier to do it with a traditional for. At this point, you should now be able to access all the elements in an array list using a for loop and a for each loop. Thanks for watching.